Welcome. Today we are going to take a look at one of the most important topics in O-level mathematics. Okay, so this is a set and set notation. Okay, so today we are going to look at sets and we are going to explain the basics of this set. Okay, so our objectives of this lesson are to make sure by the end of it you are going to understand what is a set. Okay, so you're going to understand what is a set. Then the next objective is you are going to identify and describe elements of a set. Okay, so given a set, we're going to identify and describe the elements of a set. Okay, then the other thing is we are going to use the proper set notation. Okay, so we're going to learn everything about set notation and you're going to be able to use it after this lesson. Then the next thing we are going to be able to differentiate between the types of set. Okay, there are types of sets which are finite, infinite, empty, and the other examples of sets. Okay, so we're going to be able to differentiate between them and explain what is the meaning of each of them. Okay. Then the other thing is we are going to be able to represent sets using listing and set builder forms. Okay. So we're going to list the elements of a set and you use set builder forms to list the element of the set. Okay. So this is the lesson. So make sure you are subscribed so that you won't miss the next lesson about this set where we look at Venn diagram. Okay. Okay, before we go any further, let's first answer this question. What is a set? Okay, so by definition, a set is a well-defined collection of distinct objects considered as a whole. Okay, so if you take a well-defined, you define what it is. Okay, it is a definition. We know what it is, and these objects they possess a same characteristics. Okay, so we can say it is a set. Okay, so let's say we want to write a set. Okay, so we can say the first thing you can say a set A is a set of numbers less than 10. Okay, so you can say numbers less than 10. Okay, so this means that a set A, okay, let's say talk about numbers. Let's say they are into their whole numbers to avoid confusion. Numbers less than 10, they are infinite, but we can say that they are whole numbers less than 10. Okay, so we can now say the elements of A are okay. Yeah, the whole numbers less than 10 we have 0, 1, 2, and 3, and on and on and on until we get to 10. Okay, so this will until we get to 9. Okay, here this 10 is not included because it's less than 10. Okay, so this will be a set of A. Okay, so you can see this one, it is defined. Okay, what is the definition? It is a whole numbers. Okay, distinct objective. Okay, distinct objects, they have a certain characteristics which is less than 10. Okay, so you can say this is one is a set. Okay, so the other set you can say set B. Okay, set B can contain, let's say we contain vowels. Okay, so we want to call vowels of English alphabet. Okay, so we want to know what are the vowels. Okay, we can just say the components of set B are, we can say we have R, A, E. Okay, so we can say these are our vowels. Okay, so we can say we get A, E, O, I, U. Okay, so you can say these are our vowels. Okay, so you can see that this one is defined. Okay, we have vowels. Okay, that's their distinct characteristic, and a correction, it is defined that these are letters. Okay, so this is the representation of a set. Okay, so when you say what is a set, you know that they're well defined. We define what it is, and it has a certain characteristics. Okay, so in this case, we see that it was numbers less than 10, and here you can see that the distinct characteristics was they were all vowels. Okay, so this is the meaning of a set. Okay, if we just group things together, we can say they are a set. Now let's talk about set notation. Okay, so set notation is the way we are going to represent our set. Okay, so the way we are going to represent our set, that is what we call set notation. Sets are usually represented using curly brackets. Okay, you can know these brackets are the brackets we are going to use to represent sets. Okay, the elements are separated by commas. Okay, so you separate the elements with comma. Okay, so let's say we have a set. Let's say it's a set A. It consists of whole numbers. Okay, whole numbers less than 10. Okay, so you can say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, whole numbers less than 10. Okay, they end here. Okay, so now let's take a look at the other symbols. Okay, so what we do is we say we have symbols which are used to represent sets. The first symbol is if you write a C like this and this, like a E like this. Okay, this means that this is an element of. Okay, it means that it is an element of. Okay, so this means that we can now say, let's say two. Two is an element of A. Okay, we represent it by this. Okay, 2 is an element of A. We use this symbol to represent that 2 is an element of A. Okay, so this is what you see. This 2 is in A, so you can now see that 2 is an element of A. And the other symbol is you just have to write this E and cut it off like this. Okay, this means that it's not an element of. Okay, okay, so this means that if you get a number, let's say 12 is not an element of A. In this case, 12 is not in here. So you can say 12 is not an element of A. Okay, so this is the way we represent it. Okay, and the other thing is we use these brackets to represent a empty set. Okay, so given these two brackets which are together like this means that this set is empty. Okay, it has nothing in it. So you can say it is an empty set. Okay, and the other thing is if you are given like this n a in bracket. Okay, this means that a number of elements in A. Okay, so you're going to count the number of elements in set A. In this case, you're going to count 1, 2, 3, 4, 5, 6, and you're going to find out that this element in this set has 10 elements. Okay, so given that given this, you know that it means that number of elements of A, and this one means an empty set. This one means it is not an element of, and it is used in this form, and this one means that it is an element of. Okay, which is written in this form. Okay, so this is all about set notation. Make sure you master this. Okay, let's talk about methods of representing sets. Okay, so given a set, we have a method we use to represent it. Okay, so I've already represented the set in the first method, in this first method, which is roster or listing method. Okay, so in this method, we just write a set. Let's say a set of A, which consists of the elements 1, 2, 3, 4, 5, 6. Okay, so in this case we just represented a set by writing every element. Okay, so this is the meaning of roster and listing method. Okay, so let's go to the next which is set builder notation. Okay, I want to try to represent this set using the set builder notation. Okay, in this what you do in this you say uh, x such that x. Okay, so you write it's x and the x. Okay, these are the elements. Okay, we try to describe these elements, the condition of this experiment. Okay, in this case we can say that they are natural numbers. Okay, so we can say there are first 6 natural numbers the easy way. We can now say first 6 natural numbers. Okay, so this is what we do. We just have to write x such that x and describe the numbers. Okay, the first 6 natural numbers, you just know that we start from 1 and we end at 6. Okay, so this is the way we build sets. This is the way we represent sets. Okay, the first one was listing. We just list all the elements. And the second one was that you just write x such that then you take the condition of the set. Okay, you can say if a number is less than 20, odd numbers less than 10, prime numbers less than 40. Okay, so this is the what you do. You just write x such that then you write the condition. Okay, so this was about representing sets. Let's go on to our next concept. Our next concept is types of sets. Okay, so we have different types of sets. Okay, so let's see how many types do we have. Okay, so the first we have a finite set. Okay, so if it is called a finite set, it has a limited number of elements. Okay, okay, in this case, we can say that a set which has a limited number. Okay, so we can say that numbers less than 10, this one, it has a limited numbers. Let's say we have a set called A, which has numbers 1, 2, 3, 4. Okay, so this is limited. We only have these numbers. Okay, so we can say that this is a limit number. Okay, so then we have an infinite set. Okay, in this case, the elements are unlimited. Okay, let's say we want to we have a set. Let's say our set B, it consists of natural numbers. Okay, so we know that our natural numbers start from 1 and they go up to infinity. Okay, so they are unlimited. Okay, so this is what we call an infinite set. Okay, and the other thing what we call is an empty set. Okay, as the name suggests, it has nothing. Okay, it is empty and no elements. Okay, Okay, so if you have an empty set, let's say its empty set is called C, you just write it like this. You just put two curly brackets, okay, or like this, okay. So this means that the set is empty, okay. Then the other thing is, let's go to an singleton set, okay. Okay, a singleton set is a set where it has one element, okay. Okay, let's say our element, our set Our set G consists of only one number. In this case, let's say it's 7. Okay, so this is what we call a singleton set. Okay, then the other thing is we have an equal set. Okay, an equal set is where a set has same elements. Two sets. Okay, we can say equal sets when two sets have same elements. Okay, so if we have a set, let's say it consists of A, B, D. Okay, this is the first set. Okay, it is represented in this form. We can say it is equal to if we write T, B, A. Okay, we can see that these elements are the same. Okay, so we can say these sets are equal. Okay, then let's go on and so talk about equivalent. Okay, equivalent set. Okay, equivalent sets. Okay, these are the sets where the same number of elements. Okay, they don't have to be the same set, but if the number of elements are the same. Okay, so let's say you have a set 1, 2, 3. Okay, it is equivalent to another set if it is, let's say, X, Y, Z. Okay, here we can see that we have three elements and we have three elements here. Okay, so we can say these two sets are equivalent. Okay, then let's go to the last one, which is universal set. Okay, this is we're going to use this universal set a lot. Okay, the universal set is a set where we have all elements under consideration. Okay. Okay, in this case, let's say we are talking about alphabet letters. Okay, so all alphabet letters they follow under the universal set. Okay, and the subset can contain vowels, can contain other like consonants. Okay, but the universal set is containing alphabet. It's containing all elements under consideration. Okay, so we're going to see how we use universal set and all these sets. Okay, so make sure you remember these set names. Okay, so that when they come you'll be able to apply. But let's talk about visual representation of a set. Okay, we represent sets using a diagram called a Venn diagram. Okay, so this is a diagram we just use to represent set. Okay, so I'm going to write three sets here, and I'm going to show you how we can represent it. Okay, let's say we have three sets. The first set is universal set. It is represented by U. Okay, here we can see all our sets consist of natural numbers from 1 to 10. Okay, so let's see how what you see in set A. Okay, here we can see that our set A consists of odd numbers. Okay, so if you are given a universal set, this means that our set A is going to fall under this. Okay, so you're going to take odd numbers from this set. Okay, let's go to our set B and see what is in there. Okay, here we can see that our set P consists of prime numbers. Okay, so if you want to visually represent this set, okay, the first thing is to write a universal set. Okay, a universal set is represented by a, a rectangle like this. Okay, so this is where all our elements. Okay, a universal can be represented by this symbol. Okay, okay, it's not so good. Can be represented by this symbol. Okay, okay, if you see that symbol, which look like a snake somewhere like that. Okay, so this is the representation of universal. Okay, so in this universal, you're going to write all these elements. Okay, but first, what you do is you first write A. Okay, so the first thing is to write A in each circle, then you write B. Keep an option for overlapping so that you may have elements which are in A and B. Okay, so here we have B. Okay, so the first thing you are writing the elements of A. Okay, which are the elements of A which are not in B. Okay, here we can see that we were talking about odd numbers. Okay, so odd numbers start from 1. Okay, and 3. 3 is also in B. Okay, so we write it here. Okay, then we have 4, which is not in any of this set. 5 is here again. 6 is not here. 7 is here. Okay, 9 is not in B, so it's here. Okay, now we will go in and talk about prime numbers. Okay, let's go 2. Okay, 2 is here in B. Okay, it is not in A, so we write it this side. Okay, then prime numbers, we go on and see that others are there. Okay, only 2 is not there. Okay, now we have already written these numbers. 1 is there, 2, 3, and we have written 5, 7, and 9. Okay, now we are left with 4. Okay, now we just have to write outside 4, 6, 8, 10. Okay, so this is how we write a set. This is how we represent a set in Venn diagram. Okay, so this is a Venn diagram. The first thing you're going to write the elements of A which are not in B. Then we write the elements of B which are not in A. Okay, then we write the elements which are in A and B. Okay, these are the A and B. Okay, then we write the elements which are remaining. Okay, so this is how we represent uh, our sets. Okay, the other thing is when these ones are not overlapping, we can just write two different circles like this. Then write the elements of A here and the elements of B here. And if there is no universal set, you don't write this rectangle. Okay, so this is a visual representation of set. Okay, so that was that. Thank you for watching. So make sure you subscribe so that you won't miss next when we do many examples on this set. Okay?